In this segment, we'll begin a discussion of the bottom half of herd animal, and we'll look at generics and instance inner classes. Now, each herd animal keeps track of its herd, the herd animals that are following it as a leader. And one way to do that would be to keep an array list of herd animals, but we're going to use a different approach and illustrate several concepts in the process. We'll keep track of our followers, and there'll be more on the follower class in a moment. As we were saying, we keep track of our list of followers in a member, myFollowers, which is a linked list. Now, linked list has exactly the same methods and behavior as ArrayList, but it uses a linked list internally instead of an array to keep track of its objects. The Java libraries offer a variety of collection classes, as we've mentioned earlier, and choosing which to use is a trade-off of strengths and weaknesses. Adding and especially removing objects from a linked list is faster than for an array list, but fetching an object by index is slower. A linked list can fetch objects by getIndex, but it indexes, quote-unquote, by traversing the linked list to get to the desired node. So it's pretty slow. Now, we won't do that to followers, or myFollowers, so a linked list is a reasonable choice. Recall also our earlier discussion about heterogeneous collections of objects and the need to be sure of what type you add to them and to downcast to that type when you retrieve objects from them. We said that there was a better alternative, and myFollowers is an example. It uses generics to simplify the management of types on the linked list. Now, adding follower in angle brackets after linked list in both the reference declaration and in the new operation, we give the compiler these instructions in effect by doing that. First, this linked list should hold only followers. And if any call, for instance an add, tries to add anything but a follower to the linked list, make that a compile error. And because of the checking done for that point we just made, we can then assume that only followers will make it onto the linked list. So don't require, telling the compiler now, don't require that we add a downcast of parenthesis follower when retrieving things from the list. Just do the downcast automatically. So here's an example in the notes that illustrates the idea a little further. Got a vector that I've declared just to have a non-follower object to play with, a follower reference, and then a linked list, myFollowers, with the generic notation, angle bracket follower on it. And what that means then is that if I attempt to add a vector to myFollowers with this add call, that won't compile. The compiler will give me an error message for it. Only allowed to add followers, or maybe something derived from follower if I wanted to. The other side of the coin is that if I do a get to retrieve an item from myFollowers, I don't need a downcast, as I would have without the generic notation. Instead, I can simply assume a follower is coming out of it and assign that directly into a follower reference. So the notation is a lot less cumbersome with a generic list. Now, it is important to understand that generic notation does not create a new type of linked list that stores followers. You get the same old linked list of object references, and that could in principle hold anything. But your little deal with the compiler, arranged with that angle bracket follower thing, ensures that the linked list never sees anything but followers. You can't add anything else to it, and so you can write code that assumes that. And the downcasts then will be done automatically. All the magic is done during the compiling process. There's no extra runtime checking that results from using generics. If you use an iterator, and we'll go back here to the main source, if you use an iterator to walk through a generified collection like myFollowers, then it must also follow the same deal, as you can see right here. And the compiler requires you to qualify it with the same generic notation as the collection. So the loop in lead followers here, for instance, uses iterator of follower. And as a result, there's no need for a downcast on the iterator next. We're in fact assuming right off that it returns a follower, and then we can call leader step on it. No downcast needed. Now that's a brief overview of using generics, and it's enough for this topic. A later topic will go deeper into generics. So now that we have a linked list of followers, what exactly is a follower? Well, from the code, it's obviously an inner class. And in step, if you look up here, we create a follower object each time one herd animal decides to follow another. And then we call the leader's add follower to add it to the leader's my followers list. Each follower object forms a connection between a leader herd animal and one of its followers. The class might have been named something like following relationship, I suppose, but that was too much of a mouthful. Now, the leader controls its followers by calling methods of follower. There's leader step, for instance, which just augments the follower's location by whatever step is being passed, which is the step the leader made to cause the follower then to move in lockstep. And then there's change leader, which sets the my leader of the follower to a indicated new leader for when we're handing our followers off to a different leader, and then it adds that follower, this here, to the new leader's list of followers. But something very interesting is going on here. Follower doesn't have loc or my leader members. Doesn't have any members at all, as a matter of fact. Herd animal has those members. Can an inner class refer to members of its outer class? Yes, if it's an instance inner class. And that is actually rather surprising when you think about it. A static inner class like animal range, looking over here to the animal class, can't refer to outer class members. Let's try it here. Let me just set the velocity of the animal to null. Well, the compiler error I get here says cannot make a static reference to the non-static field VLC, which is compiler talk for you can't use your outer class's member data. Now, it's tempting to think that it should be able to. I mean, the VLC is right down there, right? The range is right inside of the animal class, the outer class, let's call it. But that's type nesting. It means that range type is within animal type, but it doesn't automatically mean that every animal object must have a range object inside of it. Indeed, we could create a range object without any animal object existing at all. All we'd have to do is do a new animal.range, and we can create one that doesn't have any animal in existence at all. The normal relationship between inner and outer classes in almost all languages is that while the types are nested, range is inside of animal, there is no necessary association between inner and outer objects. One may exist without the other, and vice versa. There's no particular outer object that a given inner object belongs to. No particular animal object, for instance, to which a given range object belongs. So it makes no sense for an inner class method to refer to outer class members. But unique among all languages, a Java instance inner class, non-static, may refer to outer class methods and members. And this is so because every instance inner class object, going back now to herd animal, like follower, every instance inner class object has an outer class object that it belongs to. Now this connection is formed when the inner object is created, like up here. When a specific herd animal creates an inner object, a follower, then the follower inner object is attached to that herd animal for life. Like the proverbial duckling that decides that the first thing it sees at birth is its mother, a newly created follower object, in a sense, looks at the herd animal that created it and says, Mommy. I've even got a diagram to that effect right here in the notes. From then on, the follower object uses herd animals, if it uses herd animals, members, or methods, its mommy's members or methods, the herd animal that created its members or methods that are being referred to. There's actually a hidden reference added within each follower object. Modify that here to indicate which herd animal it belongs to. And it's not called mommy, but you can refer to it as herd animal.this if you need to. Often you don't really need to. In a sense, it's a context object sort of reference, but to an outer object. So within a follower, then, this means the inner context object, the follower object. Herd animal.this means the outer object, mommy. So, question 1, please rewrite, actually do this if you like in a compiler, rewrite the statement my leader equals LDR from the change leader code here to explicitly use a reference before my leader, so we understand what we're referring to there. And returning from a pause, you can write herd, as I was just saying, herd animal.this.myLeader, and you'll notice the compiler has no complaint about that. It's redundant, but allowed. And therefore, it is the mommy's myLeader, in effect, that is being modified. The myLeader of the herd animal that created the follower in the first place. Now, because of this connection, inner or instance inner objects are often used as representatives of their outer object. They have full access to the outer object, but they present a small set of allowed actions, leader step and change leader for instance, to other objects. A herd animal or any other object holding a follower reference may make the follower's outer object take a step or change leaders, but nothing else. And a given outer object may create as many inner object representatives as it likes and pass them wherever it wants. An animal or herd animal could create as many followers as it wanted to. Now, another question, just to sort out how all this works. Could a static inner object use static outer class methods and members? We'll use range and animal as an example. And reason this out based on what you know about statics and context objects. After a pause, yes, it can. A static inner object doesn't have a mommy outer object, but using static methods and members, which don't need a context object, is still okay. We have a static range, for instance, here in animal. Let's do a set range call and pass this to it, and you'll notice it compiles just fine. Static member call on a static, modifying a static method, and if I wanted to write range equals this, I could do that also. Same deal. We can access static methods and members from a static inner class, but as we saw earlier, not instance methods or members. And then another question, assuming that follower were public, it is private here, but if I made it public, then could I create a follower object in the main method of the app? What about in the static method of herd animal, for instance? Let's go ahead and put a main down here at the bottom of herd animal and try it out. What do you think is going to happen if I try to create a follower here in a static main? Turning from a pause, if you said no, and you can see it is no, we get a compile error, because there'd be no herd animal object to connect to, you're on the right track here. The compiler actually says the value of the local variable, well, it complains about not being used, but no enclosing instance of type herd animal is accessible. What that really means is there's nobody to be your mommy here. And there is actually a notation you can use to do this. If you can get hold of a herd animal object then you can add it right before the new. You could say like ha.new if ha were a herd animal, and then the thing would compile. But you have to actually have one to give to the new so that it knows who mommy is. And you can see then that does actually compile. This is a very rare notation. You almost never see this used. Maybe 1 in 10,000 lines of code. Almost all instance inner objects are created in methods of their outer object so that they know who mommy is as soon as they're created.